And there are the past 24 hours of the closest star in SDO 171 angstroms. And welcome to the Daily Space Weather Show. We'll also show some different imagery here. Some more 24-hour videos from Solar Dynamics Observatory. Here is 1700 angstroms plus the 171 angstroms difference imagery. That 1700 angstroms is similar to the surface that you would see from Earth with the unaided eye. Well, preferably with a solar filter, let's just say that. And these are bands of the ultraviolet wavelengths. Here we've subtracted the 1700 angstroms and added 131 angstroms to the difference imagery of SDO 171. The house favorite, I might add. So those are all 24-hour videos, and let's take a brief look at what is going on as far as sunspots. So there is December 25th and December 26th to date. And we have a stagnant sunspot number since yesterday, so no reduction or growth. We are expecting a decrease in sunspot number tomorrow as many groups are setting on the western limb. There is the colorized magnetogram from SDO. And let's move on to take a brief look at volcanic eruptions, courtesy of volcanodiscovery.com, by the way. These are the erupting volcanoes. Suminose Jima 6,000-foot ash plume, Semeru 15,000-foot ash plume, 15,000-foot ash plume over Merapi, Popocatépetl volcanic ash not detected, Fuego exploding flight level 160, Nevado de Ruiz. A seismic activity has increased on the 24th, and since then, I don't know. No major ash plume there, it looks like. Moving right along to Reventador, volcanic emissions possible there in Ecuador, and sporadic puffs from Sabancaya in Peru are a reminder to not pole vault the caldera. That could be unhealthful. Next, moving on to seismic activity. There are the past 90 days, conveniently brought to you also by volcanodiscovery.com. Now, we do have a small earthquake swarm in Alaska, so those could be the predecessor to a larger event, so be aware of that, our Alaskan viewers. Earthquake swarm there around Anchorage. We'll call out quakes of a 5 or greater magnitude for the past 24 hours. Starting out with Dominican Republic had a 5.3. That was at 7:24 this morning, Universal Time. Papua New Guinea had a 5.1 at 13:11 Universal Time. South Sandwich Islands had a 5.0 at 14:12. Almost exactly 1 hour after the Papua New Guinea quake. And those are the quakes. Those are the quakes of a 5 or greater magnitude. Next, some more imagery of the closest star. Here is we're back to the classic SDO 304 angstroms wavelength, which is not what I'm showing at all. There we go. That would be the thing I just said is shown. That's much better. Ionized helium from SDO. Quite a few large plasma filaments there on the solar disk, which we will cover later in the video. Any one of those could become a coronal mass ejection. Looks like we've got some new active regions there rising in the east as well. Are they sunspots? We'll cover that later in the video also. First, some solar stats. Radio flux currently at 154 solar flux units. 154 is where that line will be plotted next once it upgrades. We're a little bit ahead of the update there, rather. The update from Solon.info, 154 is the radio flux depicted by that there black line. We are expecting minor geomagnetic unrest conditions tomorrow night, December 27th into December 28th, caused by a minor coronal mass ejection impact. It'll barely be a blip. It's quite diffuse. It won't be a major geomagnetic storm, if it's anything at all. and we do suspect it will be something. And there is the Enlil spiral from NOAA, effectively NOAA's forecast, more or less. And moving right along to Earth's magnetic moment from space. So here's what's going on. Out to about 12 Earth diameters there, folks. Kind of roughly the size of Earth's magnetosphere, give or take. 12 Earth diameters for the past 4 hours, depicting magnetohydrodynamic pressure. Our Geospace Magnetosphere movie. Ground magnetic perturbations map also brought to you by the Space Weather Modeling Framework, depicting magnetic flux density at ground level for the same period of the last 4 hours. So pretty uneventful there. Again, we have geomagnetically calm conditions. KP 1.33 is the planetary K index. KP 1.33. Next real-time solar wind will bring you the Discover and the ACE. So there's the ACE first, and it does have some recent missing data. We'll show you the latest. There you go. There's the latest from the ACE. And the Discover is more up-to-date, although it does have a missing patch as well. The Discover showing about 6 protons per cubic centimeter for the solar wind density. Solar wind velocity here, about 473 kilometers per second. GOES magnetometers are fairly smooth, a little bit higher highs and higher lows than 3 days ago. There's a 7-year graph to contextualize what the GOES 16 and GOES 18 magnetometers have been detecting. And next is our top view ecliptic plane field plot. So Earth is in a South Pole sector, shown there in red. Expect Earth to remain there for a few days. Here's our line of sight ecliptic plane field plot. Probably at least 2+ days of a South Pole heliospheric sector, magnetically speaking. Here's our line of sight field plot. The sun's B field depicted here in blue. Polar fields in red and green. Photosphere fields in grayscale. If you're wondering what that is, the photosphere is where sunspots occur. The polar fields occur in the solar corona, which has its own. The plasma in the solar corona has its own magnetic fields. Speaking of which, there's our coronal hole line of sight field plot. South Pole coronal holes here on the Earth side of the solar disk, except for at the southern polar region. So basically, these are north, and these are south. Transequatorial coronal hole rotating in here, the most geo-effective kind. It's our favorite kind on the channel, because it is the most likely kind to produce some interesting space weather. So coronal holes are the source, or you could say are at least associated with high-speed solar wind. Perhaps it's a magnetic differential at their edges, but let's don't get into the minutia of the particle physics of it. Perhaps we should ask a particle physicist a question. What do you think? Should we ask a particle physicist a question about coronal holes? What do you think? If you want to ask a particle physicist a question, go do it at smashomash.com/forum, smashomash.com/forum. And perhaps we'll even have your question answered. So there is our sunspot number, which is what we're on next. Sunspots. Yeah, people count them. People get mad about them. People lose their you-know-what over them. Sunspots. There is the data from ROB, the Royal Observatory of Belgium. They've been flat since yesterday, which is why I said they've kind of been stagnating. Anyway, moving right along, here's our flare probability monitor and scoreboard. The likelihood of large solar flares not all that high, but the highest area is certainly in the west. So we may have some new sunspots showing up there in the east, but at the moment, the most likely place to see a large flare is definitely over here in the west. That's my story, since it's factual, and I'm sticking to it. Here are sunspots from SDO Continuum, and again, not a lot of changes happening here. Do we maybe have some new groups over there in the east? I'm not so sure. Those look like plages. Although there is a new sunspot formed right here, just to the south of the equator, almost right on the equator there. And you can expect to see sunspots at all latitudes where they are likely to occur as we get closer and closer to solar maximum. Moving right along to energetic particles. We had a minor proton event there. It's barely even worth noticing. Here, I'll show you the last 7 days. The last 7 days have been very uneventful for solar energetic particle events. Next, flares, and don't get flares and CMEs confused, folks. Solar flares and CMEs are very different. Coronal mass ejections are primarily protons. Solar flares are photons of the X-ray type frequency and energy. Photons, not to be confused with protons, very different things. Imagine a fan blowing air, those are protons. Imagine an X-ray machine or a flashlight blasting out photons. See the difference? Matter versus photons, a very different thing. Anyway, no major flares for the past 24 hours. Here come some excellent wavelengths through which to view solar flare activity. 131 angstroms from SDO. And let's don't forget 94 angstroms SDO. Again, you can expect a rising likelihood of large solar flares in the west, and it looks like the largest flaring activity was indeed from behind the limb, exactly where we forecasted it to be on yesterday's video. Facts. They can be very inconvenient to people that are bad at forecasting. What do you think? Correct me if I'm wrong in the comments. Next, a star chart. This is what's going on overhead right now, Lehigh Valley. Next, a solar system forecast. We show you where things are today, and then we move things ahead 1 week. There are things today. There are things on January 2nd as the year dwindles to nothingness. Next, the astronomy photo of the day, which is Eta Geminorum, a massive reddish star there that is illuminating this even more massive nebula known as the Jellyfish Nebula. So pretty sweet imagery there. I have no idea where it came from. I don't memorize stuff like that. I would never do such an insane thing. And on that note, here's a quote from Einstein. Never memorize something you can easily look up. Einstein understood the finite capacity of the human mind, that it isn't all that different from a hard drive, although Einstein probably didn't really know what a hard drive was. He's a little bit too old for that. But they were out by the time Einstein croaked. So anyway, that's by David Payne. Shout out to David Payne. Nice imagery there of the Jellyfish Nebula. No idea what wavelengths. I imagine it's probably visible light, but don't quote me on it. It could be various chemical spectra. I just don't know or care to look it up. This is basically just for the aesthetic viewing pleasure of our daily space weather viewers. And where's that Eta Geminorum, or whatever it's called? There it is. There's the star that's illuminating the whole doggone thing. Eta Geminorum, the featured star on today's astronomy photo of the day. Anyway, now it's time for CMEs. They're pretty exciting when they are. Although when they're not so much. There is a pretty good one out of the northwest there. Besides that, pretty quiet. That's 104 frames from Christmas. Here are an additional 88 frames from today. And again, things have been pretty chill when it comes to CMEs. We'll also show LASCO C2 and C3. Let's just zoom all the way in here. It's been a pretty uneventful 24 hours for coronal mass ejections, in my opinion. Let's also cut to our custom 24-hour videos. There's 304 angstroms SDO along with C2 and C3. Should be enough to show any plasma motions, especially if there are any earthly directed coronal mass ejection events. And I don't think there are. Anyway, that's what's going on. And here are some more fantastic views of the closest star there. Here we've put together 304 angstroms difference imagery along with 193 angstroms raw SDO AIA instrument. So fantastic depth is shown there in those wavelengths. And by the way, thanks to all of our new YouTube viewers. Congratulations on realizing that the channel exists. Anyway, let's move on to filaments. It's about that time. So here come filaments. There is Cerro Tololo's ground-based hydrogen alpha imagery. And like we said yesterday, lots of filaments. The sun is continuing to withhold plasma as well. So a little bit of a plasma shortage. And we are expecting to see additional series of events in the coming year or two, as we're still like about 8-10 months away from solar maximum. Anyway, here's the latest image. I just want to briefly count filaments. We'll call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll say 12 filaments. So a similar number to yesterday, depending on how you decide to count them. Some of these may be the same one. It's a little bit tough to look at. It's a little bit tough to count without getting real down into the magnetic weeds on trying to figure out which filament is the same channel and so on. But quite a few filaments. And before we get to bonus features, how about the latest from the GOES 16 SUVI? So things looking pretty stable here at the moment. There's the full disk view, and it's time for bonus features. Starting out with satellite charging hazards. We ain't got none. No surface charging or internal charging satellite hazards at the moment. GOES electron flux in a normal operating range. I mean, you want to see a 7-day? There you go. There's a 7-day. It shows you an electron storm, as well as a bit of a cratering there during some mild geomagnetic events. Here is the 1-year graph of the electron flux. The relativistic electrons located at about 300 kilometers of altitude, the electrons in the F layer of the ionosphere. There's the forecast model, and yeah, expecting the next update to be flat, followed by a mild to moderate uptick. I would tend to disagree there, because if we do have even if we have a minor CME impact tonight, those readings will become erroneous, and we'll see a big reduction. So, expecting that second green box to be way off, especially if we do have a CME impact tomorrow night. Next, the ionosphere, the layer where the electron flux is measured. And yeah, I'm supposed to be down there. Yeah, that's where I'm supposed to be. That's right. Here's the layer where the electron flux is measured. The F layer. It vibrates a lot. The gas is very diffuse, and you've got ionizing radiation blasting in on the daytime side of the planet. And you've got the portion of the ionosphere on the opposite side trying to reach static equilibrium with the surrounding atmospheric layers. The F layer of the ionosphere, folks. Here's the anomalygram. The last was the raw vibrational frequency. This is the anomalygram. Anomaly in megahertz from a 30-day median. There's the latest 2315. Here's the Global Ionosphere Nowcast. The WHAM, the whole atmosphere model, depicting total electron content and anomaly, as well as maximum usable frequency. An anomaly for you radio users. We'll close out space weather with total electron content. And then we will blast through meteorology at a breakneck pace. But first, the latest continuum and latest colorized magnetogram. So again, we do have some activity up here. Are they sunspots? Well, the answer is no, not yet. They could be forming, but so far, not so much. Now that right there, that is definitely a sunspot. So at least one new group either rose or formed there over the east. Again, the most likely place for large solar flares is now going to be in the west. And let's move on to meteorology. So we're starting out meteorology with some big waves in the Pacific Ocean. There's the North Pacific. The world's largest waves right now are up there. They're about 40 footers. Way out in the middle of nowhere there, northeast of Hawaii. Not exactly a populated portion of the planet, indeed, in the giant desert known as the Pacific Ocean. The argument could be made that the Pacific Ocean is the world's largest desert. Anyway, I won't make that argument. What I'll do is show global weather patterns down to the lower 48. Surface winds of the eastern world seen here. Jet streams of the east seen here. Jet streams of the central world are next, followed by surface winds of the central world. Surface winds of the west. And of course you can see that powerful low there out in the north central Pacific. Here are the jet streams of this side of the planet. Here are clouds and fog as atmospheric material strives to reach static equilibrium. Clouds rolling in to eastern Pennsylvania. Next, our snowpack map. That is our snow depth report from windy.com. They've got a free mobile app, by the way, if you like it. You can download it at no cost. I guess nothing's technically free, but you would create some kind of a stat that looks good for Windy's clicks or something like that by downloading their app. We have absolutely no vested interest in this, windy.com. It's got lots of features that you might like or might not like, in which case don't download it. Next, our weather.gov map. This is where things are lit up, and we've scrolled down to show you the key. How's that for a value-added service? There are your weather warnings, and those orange areas are blizzard warnings. Yeah, blizzard warnings. So here's where the snow's going to be falling. Snow depth change in inches over the next 3 days, the GFS 72-hour model. I'm not going to explain it. That's where it is. Here's pressure and precipitation as a low loiters over the central portion of the U.S. there, right around the Mississippi Valley. It's a loitering low. It kind of expected to sort of hang out around eastern Kansas and Missouri and just take days to move, slowly making its way to the east-southeast. A loitering low, folks. GFS 72-hour pressure and precipitation forecast. As some ice storms continue to happen in places like North Dakota and Canada. Temperature anomaly forecast in degrees Celsius is the next. That's what's going on with temperatures for the next 72 hours according to the GFS model. And I am out of here, there is your lightning map. That's about the last 10 hours. Some lightning in the Atlantic there, southeast of Bermuda. Do we have any continuing cells out there? Well, let's take a look at our real-time lightning map from lightningmaps.org. And there is the real-time lightning map. And we have some Atlantic, some Pacific, but actually quite a low number of lightning strikes at the moment, only 37 strikes per minute. Hopefully that hasn't sent you running into your bunker. By the way, if you enjoy the content, don't forget to press the like button. Do yourself a favor if you're new to the channel and get the world's most comprehensive daily space weather videos delivered directly to your YouTube feed. You might even actually see them in your subscription feed if you're lucky. Once again, thanks to our new YouTube subscribers. Press the like button, share, and comment. Otherwise, we will find you, we will shame you, and your soul will be left intact without being cast into an ever-deepening and darkening abyss. SmashOmash.com is the homepage, by the way, so support the channel via clicking our links, sharing our content on social media, picking up merch, shopping at our Amazon and other shops. Thanks to everyone who has. We'll close out with U.S. Doppler radar as that loitering low loiters. There is the lower 48 view. Clouds and fog. And the water vapor map giving us a great view of that rotating low. And part of the reason why it's kind of weak, folks, is because it's surrounded by dry, massive air. So this is like high pressure air. This is like lower pressure air, these moister regions right here. And that doesn't help things. So it's a little too dry there over places like Kansas. And it's not tending to lead to a whole lot of precipitation. There is insufficient atmospheric moisture to lead to major storms. No atmospheric river is fueling that. Anyway, here's your recap Doppler radar. Here is clouds and fog. And here is the water vapor map once again. And here is me closing this thing out because it is time to get this onto your screen. So see you soon from the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.